Okay, so we're back with the code here. In the last episode, we still had some little glitches, and that's totally because I forgot a simple else statement here. So I'm currently inside of the try move function. If we have a piece, and if the move is not valid, however, if you have a piece, you're dragging the piece around, and you're doing a move that is invalid, we didn't really clear, these things. We didn't really reset the start drag. We didn't really reset the selected piece. And also we didn't move our piece back to where it should be. So that's exactly what we do here. It's simple lines that I forgot. And sorry about that, happens sometimes. So if it's not a valid move, we do an else statement. And we do move piece, you're moving the piece, or we can just copy and paste what we had here. Like this. Don't actually need the return here, but we'll leave it here anyway. So we move the piece back to its original place, so the start drag in this case. Then we reset the start drag. And we set the selected piece back to null. This way, the little glitch we had, like the really ugly glitch we had where we just place piece wherever, doesn't really work anymore. As you can tell, I'm dropping the piece where it doesn't really belong, and it's not going to work unless I place it somewhere where it does work. Now, in checkers, there is a rule. Well, sometimes it's an else rule, sometimes it's not. But assume that we're on the black team right now. We are on the black turn. And we have this kind of setup here where you could actually kill a piece if you jumped over it. And if you have the opportunity to do so, in some house rules, in some checker games, you have to do it. It's a rule. So if you have like the opportunity to kill something, there is no other move you can do. So you can't move here, you can't move there, you can't move this piece. You absolutely need to move. In this case, it would be this piece here, because this one can actually kill. And that's what we're going to do today. So we're going to make sure that we actually force the player to do this move if he's able to actually do this move. Now what I'll do is I'll go back inside of the piece class, and we'll create another function. This one is going to be called is force to move, and it's going to return an actual boolean. Now what we'll get right here is a reference to the piece. So ref piece. Or you know what, that's a reference to the board again. We don't need to define it. So the board itself, which is a two-dimensional array, don't forget. The board, we also need the position of the piece actually. So int x and also int y. Okay, so let's check, is the piece white first? So if the piece is white, we can only kill going top left or top right. So we're going to go ahead and just check if there is something in between those two pieces. So let's start by checking bounds like we like to do. If x is bigger or equal to 2, and y is smaller or equal to 5 in this case, because we're on the white team and you're going up, then piece p is equal to board at the index x minus 1, and also y plus 1. Now that is the piece top left of you, so basically if there is a piece there, we have to kill it. So let's keep doing the check. If there is a piece and it is not the same color as ours, then we need to kill it. So if p is not equal to null, and p that is white is not equal to our is white, if that is the case, then check if it's possible to actually land. Check if it's possible to land after the jump. So if board at x minus 2, y plus 2 is equal to null, that means it's actually possible to land, and we do a return true. So in this case, it would be forced to move. And now, we do the x minus 2. That's why we actually do the bounds at the very beginning, because we need to check 2 tiles to our left and also 2 tiles to our right sometimes. That is only for top left. Let's copy that actually and do it for top right as well. Same exact thing, we just need to reverse a few things here. So if x is smaller or equal to 5 and y is smaller or equal to 5 as well, then is that fine? No, x here becomes x plus 1 because we need to check on the right side, and the landing spot would be x plus 2. And that's going to be working for the white team. Now if we just go down here and we do a else for the black team, we pretty much just take the same exact thing and we do bottom left instead. So first one is bot left, and after that, that's going to be bot right. Now as far as the number that goes in here, they're a little bit different. We do the x stays the same. Now the y is going to be a little bit different. It's going to be bigger or equal to 2. So we don't check, below the actual board. In terms of the pieces, it's going to be x minus 1 and also y minus 1. That's fine. Same thing here. We reverse that. And the bottom right, that would be fine on x. And the y is going to be bigger or equal to 2. Okay, now in terms of this, same exact thing. So minus 1 in the y instead, and also minus 2 in the y here. Okay, so that covers it for being forced to move if you're white or if you're black. However, we also need to check if it's a king or not. So I'm a little bit confused here on how exactly I will be doing it. I have another implementation of this. I've done this earlier, but what I have is just like a whole duplicate of this. These two conditions in another condition called is king. But I think that's a little bit too messed up. I think we can actually do the same exact thing we did with the other one. Just by saying, are you white or are you a king? If that is the case, then run this. If you enter a return, that's fine. And here we'll do if is black instead, if is not white, or is a king. Let's quickly just collapse this and do we return false at the end. So it's going to run through all of that condition for pretty much every single piece every turn. So is forced to move is going to be our function we call if we want to know if our piece can move again. Okay, so back in the checkerboard, I will create another function that is going to be something that returns a list actually. So a private list of pieces, and I have to include system.collection.generic first. Let's do that. Just right here, by the way, system.collection.generic list of pieces that we'll call forced pieces, or the function is going to be called scan for possible move. Something like that. And what we're going to do at this point is just fill an array that is going to be called forced pieces. So private list of pieces, forced pieces. Pieces. Okay, cool. Let's actually instantiate here so we don't get any error a little bit later on. And we're going to be checking for every single pieces that we can move, that we are forced to move actually. Now the way we're going to be doing this is by saying forced pieces is equal to a new list every time. Oh, you know what? We don't need it up here. My bad. Forced piece is equal to a new list every time because we're refreshing that list pretty much every single time we do a scan. And then we check all the pieces one by one. So let's do a for int I is equal to 0 if I is smaller than 8, or if you prefer the pieces.length. Just in case that you want to have like a 10 by 10 grid, which is also possible in some other kind of checkers, I++, and then once we did that, we iterate the other way by saying int j is equal to 0 as long as j is smaller than pieces.length. So right now we cover both dimension of the array, and then we'll check. So if pieces at the index I and j is not null, let's start by that. So if there is an actual piece and pieces at index I and j is white, and it is the white turn, so if it's actually your turn to play, then we'll check if it's an actual possible moves or if it's a forced move. So piece at index I and j is forced to move, and then we send what we have to send. So in this case, the board itself, so that's pieces, and the x in this case would be I, and the y would be j. Just like that. So we have a really long condition here, and if that piece, that one piece that we just check through all those conditions, if it's forced to move, then we do forced piece dot add, and we add the piece at I and j. And this is going to be ran, every time we do a scan. And the reason I'm doing this in a list instead of just like keeping a force piece, which is like a single select piece, is that you might have multiple pieces that can move a single turn. So let's just assume that you have something like, whoop, I have an error. Not all code path return value. Okay, so I'll just finish this and then we'll explain what I'm trying to say here. Let's do return forced pieces. Right. So the reason we have this in a list is so you can actually have stuff like this happening. So let's just grab one of those pieces and let's move it forward here. If something like this happens in the game, then the pieces that are forced to move is this one or this one. There's actually two. So I want you to be actually able to move those, well, choose which one to move at least. So that is why we actually keep this into a list. Right. Okay, now we did the scan. We're looking for every single piece that, are forced to move, and we should actually keep track of those somewhere else that just in that function. I mean, we're never really calling that function. We're really never calling that scan for possible move. So what I'll do is I'll put it in the try move at the beginning. Why in the try move? Because I want this to be called when we're on the other side as well, when we're actually waiting for the other player to play. So force piece here, force pieces, is going to equal scan for possible move. So at this point we just check, okay, so is there a piece? We do have a piece. Is it a valid move? If it's a valid move, did we kill anything? And that is something that we're going to be checking out really soon. By the way, this destroy here, let's do destroy.game object instead. So we actually like make this disappear. And what else do we need here? Oh wait, yeah, so did we kill anything? Were we supposed to kill anything? So were we supposed to kill anything? Before we do our move, before we just conclude our turn, let's check if force pieces dot count, a force pieces dot count is not equal to 0, so there is something. And we did kill something. How do we check if we killed something? We're gonna need another boolean at the very top here. So private bool has killed. That's spooky. So if the count is 0 and we didn't kill anything, let's cancel removes. Because you had some pieces that you were forced to move and you didn't kill anything, that means it's a wrong move. So it's still invalid. This is where we actually like finish our move. At this point we still haven't done it. So let's go ahead and just say the usual stuff. So we copy this and put that here. Because you were absolutely needed to kill something. There was something in the piece count and you didn't kill anything, that means it's a invalid move. Now has killed, let's put that up here. Has killed is equal to true. And let's also reset it when we do a end turn, which is, where is it at? Right here. So in the end turn, we're gonna say has kill is equal to false. So we're just resetting back that value. Now let's quickly just try this out. Hopefully we don't run into some weird bug. We have been coding for a while. Just going to move this here. It doesn't work. It says array is out of range. So what exactly am I looking at here that is out of range? Alright, so I was debugging a little bit and I just realized that pieces, since it's a two-dimensional array, pieces.length is actually equal to 8 times 8, and it's not really equal to the usual just 8. I thought it was only equal to 8, so I replaced what I had here by pieces.length, but let's actually go back to just writing the manual 8, or just store it into like another field if you wish. But yeah, I have to do that here, else it's gonna do like this iteration 64 times, then times another 64 because we have to go through this whole thing. And also that makes me think we have to remove it at other places as well, like here. Instead of saying pieces.length, we'll simply do 8. And also here, that's in the try move. Pretty much everywhere we were looking for bounds, and that's it really. So now we can go back, have a look at what it gives us without getting some weird error. And are we going to make it? No, another out of range exception. Why is that? It's on the same exact place too. So quickly going to debug that, put a breakpoint, and we'll have a look at why this is not working. So running this few times, it seems to go up to 5, 6, 7, and it shouldn't really go past 8 actually. So I don't know why it just ended that. Okay, sorry, it's actually smaller than 8 and not smaller or equal than 8. And yeah, so that should actually work now. And let's quickly have a look at the game. We should technically not be able to move other pieces other than this one actually. So can I move this? Nope, 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 nope. I can't do the normal move. However, this one should be able to move, and it can't right now, but at least these one are blocked, which is what I wanted in the first place. So we're able to block the other move, that's fine. Let's go back to our try move function. Okay, so at this point, we are able to actually block the other move. If we have something to kill, we have to kill it. However, doesn't seem to work completely, so we're missing something. I think we're missing something in the select piece. There is something to be done here that we need to check. So we grab the piece where we're clicking, that's fine. If that piece exists, so if piece is not equal to null, and let's actually check if it's our turn as well. That'd be something good to do. So p that is white is equal to is white. So if the piece is black and it's if we're the black player, then it's gonna work as well. Then at this point we need to check if force piece dot count is equal to 0. We just go on and we just do whatever we want really, because we're free to do whatever we want at this point. Since we don't have any forced move on us. And I'll just remove the debug.log as well. However, if there is a forced move, then let's look for the piece under our forced pieces list, and we'll do if forced piece dot find. Can we do it find? Yes, we can do it find. And then we'll just name this fp is equal to p. And if that is equal to null, then we do a return. We were not able to find the piece we're actually selecting right now. We're not able to find it under the forced piece, so we just do a return. However, if we were able to find it, that means you are selecting an actual forced piece. So we'll say selected piece is equal to p, and start drag is equal to mouse over, just like we do when we just have to grab another thing, you know. So what this should have done is that we're not even able to just grab another piece if we have a forced move. So at this point we are, I need to just, since I've added another condition with the color here, I'm going to put a public field up here. So is white turn and also is white. We'll just change the color of our player on the fly via the inspector right now. Alright, so let's boot the game and have a look at this. So right now it's the turn of the white player, so we'll just say we are the white player. Let's move this, and we get a null reference that we'll check in a moment. Then toggle this off so we can play on the black team. Go here, toggle it on for the white team. We should not be able to move anything but this little piece here. And if I just click here, I'm able to drag it. So that's another error we see. If we try to move with this one, however, we're set back to its original position. Now, if I try to click on it again, doesn't work, and that's because I think the list got updated. So right now, since the list is updated, there is only one piece that can move, and it is this one. As you can tell, that's the only one I'm able to actually click. Now, can I go here? Nope. Can I go here? Nope. Can I jump here? Can't do that just yet. So we have two things to look out for. It is to reset the scan for possible move, and also this null reference exception, which okay, so force piece. Right. Force piece. Let's initialize it up here, or actually in the start. That would be way more clean. So force piece is equal to a new list of pieces. Okay, so we fixed our first bug. Now the second bug is the fact that we can't move our piece. Well, we can't really destroy another piece. And I'll quickly have a look at the code. So we do this over here. Let's put a breakpoint, have a look at why exactly this does not seem to work. Let's press on play and also do a little move. So we're on the white player. Yep, that's fine. Continue. Now we're swapping, go back to the black player, we're fine, continue. And this is where we need to check why it doesn't work. So selected piece, that is our white piece, that's fine. And we start at 5 and 3. And we go to 7, which is fine. And y2 should be 5, is that it? Yeah. So that's supposed to be working just fine. I mean, that's the right position we're jumping. Now, let's quickly step that through. If this is a jump, okay, so this doesn't seem to work right here. If this is a jump and it didn't enter this condition, but it should have. So if x2 is minus, okay, x2, yeah, that's my problem here. I'm kind of stupid. This is supposed to be x1, or actually x2 minus to x1, and just a typo again. Great. So that is fixed. That should be fixed at least. Let's play this again, and hopefully we don't get the same exact problem. So moving this here, changing team, moving this here. Now picking this one up, jumping it, and as you can tell, we destroyed one piece. Okay, so we end up having a result like this, guys, which is quite cool. So if we have a piece that we can kill, we absolutely have to kill it. Else, you know, you can't move anything else but that piece that is going to kill another one. And you actually have to do that. So that's a very good step. The next step is going to be checking for the double jumps or in the triple jumps, and you know, as many jumps as you want, so you don't actually lose your turn every time you kill something. And we're gonna be doing that. That's gonna take a maximum of 2 minutes. It's going to be really small. But then after that, we have to do the promotion. And once those two things are done, we can now jump into the server thing, which is what I guess you guys have been coming here for. That's really, you know, what has been requested the most. So I can't wait to start a server. We just have to do like a little fix to make this look a little bit better, make it feel a little bit better. And once we're done with that, we'll have a proper checkers game. And you know, we can start working on the multiplayer afterward. Or you can stop there and have like a checkers game that you have to toggle on and off to actually switch. But either way, guys, thanks a lot for watching. Thanks a lot for supporting this video with likes, with comments, with subscription. That would be great. And check out the Patreon page if you wish to support me and the other things I'm doing here, the other tutorials, the future courses that are coming, free courses. So again, thanks for watching. I will see you guys in the next one.